All right, y'all. So 8.3 support. So in support, we're going to go over synthetic division, and we'll use that synthetic division for section 8.3 college algebra. So synthetic division. Okay, so we use that when we got a polynomial being divided by a linear factor such as this x minus c, okay? So this is going to be used for polynomial division. So I'm going to write out the steps for synthetic division, and then we'll actually work a problem. So you're going to be given a polynomial. So the first thing we're going to do is write the coefficients of the polynomial. Now, the important thing, we got to use zeros for any missing terms. So they're going to be in descending order. So if we're missing any terms, then we put a 0 in for that. All right, so we write the coefficients of the polynomial, then we draw the box, and I'll show you how to draw the box. Well, how about we call it draw the bar? Okay, so the bar will look something like that right there. All right, write C. So C will be the number we're dividing by. Okay, now if it's in factored form like this, the C will be opposite in sign than the factor. So what I mean is if this was, say, x plus 2, 2 would be my C, but since it's positive here, I would use a negative 2 when I'm writing my division. If this was, say, x minus 3, since that's a minus 3, I would make my 3 positive. And y'all, you'll see me go through these, okay? So once I got my coefficients, I write my bar and I find my C, then the steps to actually doing the division. We bring the first coefficient down. Under the bar. Once I brought that first coefficient down, I'm going to multiply the number we brought down by C and place the answer into the next column. All right, so I brought my number down into the next column. I'm then going to add the column and write that answer under the bar. So I'll have me another number under the bar. So I'm going to repeat the process. I'm going to take that number, multiply by C, put in the next column. So we're going to repeat the process until done. Okay. So we'll repeat it until we get an answer in that box. The answer in the box, so the number in the box, so we're talking about this little box we get, the number that's going to be in that box is the remainder. The other numbers we have from the numbers we brought down and everything else other than the box, these numbers give us what we call the quotient. So the other numbers are the quotient, and it starts 1 degree less than the original polynomial. So what I mean, if we started out with, say, an x to the 4th, then my quotient numbers would start with my x to the 3rd, my x squared term, my x term, my number term, and then my remainder. So the quotient will always start 1 degree less than our original polynomial. Now, y'all, we're going to use it. There's 3 things I can use synthetic division for. So synthetic division. First thing I find with synthetic division, and this is the support part of it, we can find the quotient and remainder. Okay. Now remember, when we find the quotient and remainder, our C will be opposite in sign than the factor. All right, y'all, the college algebra part of using synthetic division, for it, we're going to find function values. Now, when we find function values, the sign of C does not change. So do not change the sign of C. So if they say find f of 5, then that 5 is what we're going to put into for our C. And y'all, the third thing I'll use it for is to determine if a number is a 0. Okay, so the remainder theorem on the second part here to find function values, the remainder theorem tells us that the function value is equal to the remainder. If I'm using it to determine if a number is a 0, to be a 0, the remainder must be 0. Okay, so support, we'll look at quotient and remainder. When we get into the college algebra, we'll find function values, and we will determine if a number is a 0. So, y'all, it's not bad. It's just getting used to this process right here, and that's what we're about to go over. So I'm going to give y'all a second to write this, and then I'm going to flip it, and we'll start working some examples. So the 8.3 support had 3 examples, and in the college algebra, I think there's like 5 problems. All right, y'all, so let me get my camera reset. So my first example says use synthetic division to divide. And all three of these examples will be doing that. We'll be using synthetic division to divide. So y'all, number one has parentheses r to the third minus 10r squared plus 72r minus 22 divided by parentheses r minus 6. So I get my C from this factor. So for us, C will be a positive 6. Since the factor is negative, our C will be the opposite sign. So it will be a positive 6. Okay, so the first thing I said, write the coefficients. And notice, I got my R3 term. I got my R squared term. I got my R term. And I got my constant term. So I'm not missing any terms out of this polynomial. So I don't have to worry about using a 0. So I'm going to start out by writing out my coefficients. 1 for the R3, negative 10 for the R squared, 72 for the R, and negative 22 for the constant term. Then I draw my bar, and under the negative 22, I'm going to box that off. So the last column you box off. Now over here is where we're going to put RC. And for us, C was a positive 6. Okay, so y'all, it's just a repeat process. So the first thing I said to do was bring the first coefficient down under the bar. So bring that 1 straight down under the bar. Now, we got to find the next column's number here. So to get that next number, we take the number under the bar, multiply by the C, and put that answer under that negative 10. So 1 times 6 is 6. So we bring the 6 under the negative 10. And then we're going to add that column. Once I add this column, I'll bring the next number down. So negative 10 plus 6 gives us a negative 4. So now that I got a negative 4 under the bar, I take that negative 4, multiply by 6, and put that answer in the next column. So negative 4 times 6 is negative 24. All right. 72 minus 24 gives us 48. All right, might have to break out my calculator for some of these. So now 48 times 6 gives me the next number. So when I say 48 times 6, that's going to give me 288. Right, y'all. So my remainder is what we're about to figure out. So 288 and a negative 22 give me 266. So the first 3 numbers, remember, are the coefficients of the new polynomial that we got by dividing by that r minus 6. And it starts out 1 degree less. So since this was an R3 when I started, this quotient will start as an r squared. So this tells me that I got 1r squared minus 4r plus 48. And your quotient's going to go in descending order. The r squared term, the r term, and your constant term. Now, there's two ways they write the remainder. One way, they'll give you the quotient and then say r equals 266. The other way, they'll write the remainder. They could go r squared minus 4r plus 48. And then they sort of write it in with the polynomial. So they put a plus, and then you put your remainder, 266 over what we divided by, which was the r minus 6. Sort of like when you did long division, whatever you divided by, if you was to write it as a fraction, whatever was being divided by went under that bottom. So y'all watch out, they'll use both methods on those answers, okay? I think the first two do it like this, where they write r equals the number. And then I think the third one, it uses this style right here. So y'all, we'll keep doing these. They're not bad once you get used to them. So let's try number 2.
I got a question real quick.
Yeah, I hear you.
Where'd the 288 come from?
Oh, the 288.
Missed that.
So when I did this step right here, I had the 48 on bottom.
Yes.
It multiplied by the 6, and that gave me the 288. So you're just going to repeat the process. Bring that first number down, multiply, get the second column. Add them together, take that answer, multiply by the 6, get the next column. Add them together, take that answer, 48, multiply by the 6, and get that third column.
Gotcha.
Once we added that, we had our remainder.
All right.
Right, y'all. So 3b to the third plus 21b squared plus 28b minus 18. We'll divide that by b plus 5. So this time, since my factor of 5 is positive, my c will be a negative 5. Okay, so it's always going to be opposite in sign than what they're giving us. All right, y'all, so my c is a negative 5. My coefficients, and look, nothing's missing. I got my b3, b squared, b, and my number. So nothing's missing. So we got a 3, 21, 28, and a negative 18. All right, I'm going to draw my bar, and I'm going to box off for my remainder. All right, y'all. So remember, the first number comes straight down below the bar. So my 3 is now below the bar. Remember, numbers below the bar, multiply by c to get my next column. So 3 times negative 5 gives us a negative 15. All right, add that up. 21 and a negative 15 will give us a 6. All right, y'all ready? Take the 6, multiply by negative 5, gives us a negative 30. And what you got to watch for really is the adding these signs, because I got a negative 30 and a positive 28. That's going to give us a negative 2 there. And then that negative 2 times that negative 5 gives me a positive 10. And y'all look at that, negative 18 and 10 give me a remainder of a negative 8. So our polynomial will start 1 degree less than a b to the third. So this will give me 3b squared plus 6b minus 2, and my remainder equals a negative 8. Now remember, the other way I could write that 3b squared plus 6b minus 2 plus my remainder, which is a negative 8 over the b plus 5. Okay. Now I'm just writing them both ways so you get used to it on the third one. The first two actually want this method right here. But y'all, this third one here, they want me to write the answer like a polynomial, okay? All right, y'all, so here we go with the last one in support. A to the third minus 8a squared plus 2. I'm going to divide that by a minus 3. So let's see, that means our C is going to be a positive 3. Now, y'all be careful on this one.
Eugene, can you hear me?
Now I hear you.
Because I can't hear you.
Is anybody hearing me?
I don't know why I can't, but I can't.
Yeah, I hear you fine.
So everybody's hearing me? So yeah, I don't know what's up then. Is your volume up on your computer down there? Because yeah, I've got mine all the way up now, so not sure about that. Everyone else said they was hearing me though, right? All righty, y'all. Let me tell you a trick about how many numbers you need. You take the degree, which is 3, add 1, that tells you need 4 numbers. The degree 3, add 1, I have 4 numbers. But y'all look at this. I got a degree 3 and I've only got 3 numbers. So y'all, let me see what this chat's saying real quick. Okay, now that sounds all right. So 3 plus 1 is 4. I need 4 numbers, but y'all, they only gave me 3 terms. That means we're missing a term on this. So I got my A3 term, my A squared term. I'm missing the A term, and then I got my number. So guess what? In place of the A term, we got to put that 0 for a placeholder. So your coefficients will be a 1, negative 8, 0 for the A term, and then your 2 for your constant term. I'm going to draw my box. And our C, we said, was a positive 3. So yeah, that's one way to check that you got enough numbers is take the degree and add 1. Okay. All right, y'all. So here we go. We're going to bring the 1 down.
Okay, I can hear you now. Is that just like the other ones?
Yeah.
Okay, cool. Because now that I can hear you, I would.
Yes, all these will be very, very similar. The only difference on this one is I had to add a 0 for the A term that was missing.
Okay, I'm just asking because I couldn't hear you on 1 or 2. I was trying to figure it out with my computer.
Okay.
I couldn't hear you, but now I can hear you. So we good.
Okay. All right, y'all. And I hear you a lot better, so something must have been up. All right, y'all, take that 1, multiply by 3, bring to the next column. Negative 8 and 3, give me a negative 5. All right, the negative 5 multiplied by 3 is negative 15. 0 plus a negative 15 is negative 15. And y'all, the final column, negative 15 times 3 is negative 45. And let's see, 2 and negative 45 give me a remainder of a negative 43. So remember, my quotient starts 1 degree less. So this will be 1a squared minus 5a minus 15. Now remember, this one wants me to write the remainder like this. So it'll be plus a negative 43 over a minus 3. So y'all, that's the 3 you got to do in support, okay? So then we'll have that right there. So now college algebra, we're going to use it to find function values and to determine whether numbers are zeros. So let me get this curved up paper fixed. And what's nice, the synthetic division will be the same process. So y'all, this is 8.3 college algebra, polynomial division. So like I said, in college algebra, we're going to use it to find function values. So when we find function values, we got what we call the remainder theorem. And this remainder theorem tells us that the remainder from synthetic division is equal to the function value of that number. So this is another way y'all can find stuff like f of 5 and f of 3 and all that fun stuff, okay? So let's do a couple problems where we find function values, and then we'll look at the zero part of it. So y'all, these say use synthetic division to find the function values. So for number 1, they're giving us f of x equals x to the third minus 12x squared plus 41x minus 30. And y'all look at this. They want me to find f of 1, f of a negative 5, and f of a positive 6. So I got to use my synthetic 3 times to find these 3 different function values, but my coefficients are going to be the same every time. So I'm going to start out with f of 1. So that means for f of 1, my c will be a positive 1. So we do not change the sign of c when we're looking for function values. We keep that number the same sign. So f of 1 means my c will be a 1. Now my coefficients are 1, negative 12, 41, and negative 30. So I got 4 numbers. So 3 plus 1 told me I needed 4 numbers. All right, I'm going to draw my bar and box out that last one. So all I'm looking for when I'm finding function values, all I'm looking for is what that remainder is. Because whatever that remainder is, that'll be what f of 1 equals. So other than our c being the same sign, everything else is the same, y'all. So we're going to bring the 1 down below the bar. Well, then multiply the 1 times 1 gives me 1. Negative 12 plus 1 gives me a negative 11. All right, what's next? Negative 11 times 1 is negative 11. All right, 41, negative 11, give me a 30. And y'all look at that. 30 times 1 is 30. So I get a remainder of 0. So that means f of 1 equals 0.
Okay, Mr. Eugene, quick question.
Yeah.
This is can you can you go back and tell me how you do those numbers again so I can write it down? Because that's the part that throw me off. Like when you're
These
doing
numbers?
yeah, like when you do number negative, I get it because you do 1 and 1, that's 1. Then you do, what do you do? 1 times negative
No,
12.
I'm adding these together.
Okay.
So anything up here in the columns, those are being added to get this answer down here.
Yeah, but then okay, because my brain would think you would take 1 and multiply and add all of them by 1, but you're actually taking different numbers. So like negative 11, you're doing negative 11 by 41. It's a pattern you're doing, but I'm trying to catch on to the pattern.
Oh, no. So watch this. I'm going to put a negative 5 in here for this next one.
Okay.
Now watch me. I'm going to write my numbers here. 1, negative 12, 41, and negative 30. So you're with me on that. I got them numbers from right here.
Okay.
Now I'm going to draw my bar. And I'm going to box off that last one.
Okay.
So your first step is to take this one and bring it down below the bar.
Okay.
Now to get this next number under that negative 12, we're going to multiply this 1 by the negative 5.
Okay.
So 1 times negative 5 is going to give me a negative 5.
Right.
Now to get the next number under the bar, you're going to add that negative 12 and that negative 5.
Right.
So that's what, a negative 17.
Okay.
Remember, now at this point, since the negative 17 is under the bar, we're going to multiply it by the negative 5 to get the next column.
Okay.
So let's see, that should be a negative times negative. It's going to make that a positive 85.
Okay.
Now you got a column right here. You're going to add that column to get me the next number under my bar. So let's see, 41 and 85, give me 126.
26. Okay.
Now that the 126 is under the bar, you're going to multiply by negative 5 and get me that next column.
Okay.
So let's see, that's a negative something.
So negative 5 times 85?
Well, do the negative 5 times the 126.
Okay, negative 5. Okay.
Because it's under that bar.
That is 630, negative 630.
All right. Now, add the last column to get your final answer. So that negative 630, negative 30, give me what, a negative 660. So that means f of negative 5 equals a negative 660.
Okay, I got it now.
All right, we'll see how y'all do. Here comes f of 6. So f of 6, I'm putting a 6 in for my c. My coefficients are still 1, negative 12, 41, and negative 30. All right, y'all, I'm going to draw my box. So, y'all, the first step is to take the 1 and bring it down.
Mm-hmm.
So, I need to get the next column. How am I going to get the number under that negative 12?
1, no, wait, is it, yeah, no, not 1 times negative, not 1 times 6, is it?
1 times 6, there you go.
Okay.
So 1 times 6 gives me a 6. So that's in my next column. Now, add that together. Negative 12, positive 6. That should give me what, a negative?
That is a negative 6.
There you go, negative 6. So now, what am I going to do with that negative 6 to get this next number?
Multiply by 6.
Okay. So -6 times 6 is a negative 36.
Okay.
All right, so add that column. What do we get?
That is 5.
All right, so we got a 5 there. So
Yeah.
now 5 times 6 gives me my last column.
Okay. That is going to be 30.
All right, y'all add them together. What do you get?
0. Wait.
Oh, you're fine. Yeah.
Oh.
So that means f of 6 equals 0.
Okay.
So y'all, let me tell you this. Out of these 3 answers, 2 of these numbers were actually zeros of that polynomial. Can you guess which 2 were the actual zeros? So 1 and 6 right there. Because if you get a remainder of 0, that means that the number was actually a 0 of that polynomial or a solution, remember. Remember, zeros and solutions are the same things. All right, so y'all starting to seem like y'all starting to get the hang of this synthetic division. So let's see what this second problem's doing to me. Same thing, use synthetic division, find the function value. They're giving us f of x this time equals 3 x to the 4th. So x to the 4th minus x to the 3rd minus 15x squared plus 31x minus 36. All right, y'all, let me let one in. All righty. Now they're wanting me to find f of a 5. Okay. Now, to check and see if I got enough numbers here, that's an x to the 4. 4 plus 1 is 5. So I need 5 coefficients. So I got a 1, I got a -1, -15, 31, and a -36. So I'm not missing any terms. So we have all of our numbers here.
A question. So I guess I'm missing that. You're doing the exponent of that x with the 4.
Uh-huh.
Where'd you get the +1 from?
Oh, I'm just telling you, that's how I can tell how many numbers I need. So if you just
yes, because you have a 4.
well,
Yeah,
remember I did it up here. When I had a 3, I added 1, so that told me I needed 4 numbers.
Right. Okay.
Now
Oh,
that
so
I got a 4 here,
whatever your largest exponent is, you +1.
there you go. And then that tells me how many numbers I need. That
got
sort of tells you if you're missing any of these terms or not.
Okay.
Okay.
And that's the rule for all of them, Mr. Eugene. Always add a 1, and then you'll get the F you're looking for. Like find F of 5. That's how you got it. Or no?
Well, okay. So what I'm talking about is how many numbers I need. So take that 4. So that's telling me I need 5 numbers. So I got a 1 from the x4.
Mm-hmm.
I get a -1 from the x3.
Okay.
I get a -15 from the x squared.
Okay.
I get a 31 from the x term. And then I got my -36. So I got 5 numbers. So 4 plus 1 told me I needed 5 numbers here.
Oh, I get it.
Okay, so I'm just looking at how many of these coefficients I need. Because remember, if I'm missing anything, I have to put zeros like we did on the support.
Right. Okay, I got it.
All right, y'all. So draw our bar with the box. Now, since we're finding f of 5, C is going to be that +5. So y'all, all we're going to do is spin through this until we get a remainder. So the first number we always bring down into the Now you're going what? Multiply the 1 times 5 to get the next column.
Yeah.
So let's see. 1 times 5 is 5.
Mhm. And then -1 plus 5.
There you go. So what are you getting there? 4?
Yeah.
All right. Now I need the next column. So you're going to take the 4.
And multiply. I mean, sorry. Yeah, multiply by 5.
Uh-huh. So y'all 4 times 5.
20.
Well, that goes in my next column. Now we're going to add this column and get the next number under the bar. So 20.
-35.
Oh, watch out. You got 20. You're adding them. So 20 and a -15.
There we go.
5.
So you're getting a 5. There you go.
Oh, I thought you said we were adding them. Oh, okay.
Yeah, don't subtract them. Make sure you're adding those, okay? Now, I need the next number under the 31. So I'm going to take this 5 and multiply by that 5 again.
So we
And
25.
25. So what are y'all going to do with that 31 and 25?
Add 'em.
Add it.
So
Add them. There you go.
56.
56. Now, how are you going to get my last number here?
You're gonna do go ahead.
56 by 5 is 280.
56 times the 5. So every number under the bar, you multiply by the 5 to get that next column every time. So, 56 times 5, what's that? 280?
280.
All right, break out that calculator and tell me what is a -36 and a 280 giving me.
244.
So that means f of 5 equals, you said 244, right? So there you go.
It's like you are doing a pattern, but it's so crazy because my mind cannot figure it out. Like I can't explain it, but it's like you're doing plus, multiply, plus, multiply, plus, multiply.
Well, hell, that's all I'm doing. That's all I'm doing. I'm bringing the number down. I'm multiplying, adding,
Yeah.
multiplying, adding, multiplying, adding, multiplying. So it's just a repeated process of multiplying and adding. All righty, y'all. So now let's use it to determine if a number is a 0 of a polynomial. Because before, when we had those x² polynomials, x² plus 3x minus 5 and all that stuff, we could either use a quadratic formula, we could factor them, or we did square roots to solve those. But y'all, we're looking at x to the 4s and stuff. So if we use synthetic division, we can break these down and tell if numbers are zeros or not by doing a synthetic division. So then we ain't got to try to factor something like this x to the 4th. Lord, those would be fun to factor, you know. So synthetic division saves us from having to factor stuff that big. So let's try it for determining. So determining if a number is a 0. Now, what's fun, if a number is a 0 of that polynomial, then guess what the remainder has to be? So if a number is a 0 of a polynomial,
Is it all real numbers?
then the 0, so let's see, if a number is a 0 of a polynomial, then the remainder must be, well, y'all remember that one I did a while ago where I had 3 of them? And I said 2 of these were zeros of that polynomial. Why did y'all pick them 2 to be zeros of the polynomial? What was the remainder of those 2 y'all picked? So let me go back.
Because I know she said 1 and 6, but I'm trying to think what was it about
Well,
it?
here's 1. What was its remainder?
0.
Oh, it was a 0. Here's number 6. What was its
Oh,
remainder?
0, because that's okay, that's a given.
0. So if a number is going to be a zero of a polynomial, then that remainder must be a zero, okay?
Mm.
So if I get a zero, I say yes. If I get any other number, y'all, we're going to say no to that, okay? So these will be the last three have us doing this kind of stuff. They're getting us ready for 8.4 with all this zero stuff. So y'all using synthetic division. Determine whether the numbers are zeros.
I got a question. So going back to the other page where we had a 0 is the remainder. So it was f of 1. So f of 1's got to be 0 also.
No. We're just finding what f of 1 is on this. And the function value actually equals 0.
Right.
So this one is one of the function values. What was the value of this thing if I was to put a 1 into it?
So what has to be 0 if the remainder is 0? That's what I guess I'm confused about.
Say again now.
What has to be 0 if the remainder is 0? What number is it talking about?
So to be a 0 of the polynomial, that remainder has to equal 0.
Yeah, it could be any number. He's saying, yeah, I see what you're saying, Miss Eugene. What Miss Eugene's saying is it could be any number. You see how it just so happened 1 equals 0, 6 equals 0. You see that negative 5 was negative 660.
Negative
So that wouldn't be, it wouldn't be a 0.
Right.
It's 1
So
is
I don't know what numbers will be here that might work.
Okay. I got you.
Because remember, that's the x to the third, so it's possibly got 3 real number zeros. Well, I know 2 of them because of these remainders. And there would still be one more, so I would have to go through different factors of 30 to find that other one.
I'm making it harder than it needs to be is what I'm doing.
I think you're doing that, yeah.
But hey, he asked me good questions though.
So let's see how y'all do on this one. So they want me to check -5 and 2. So they want me to check these two numbers and see if they are zeros of f of x equals 3x to the third plus 10x squared minus 19x plus 30. So I got a degree 3, so I need 4 numbers. So I got my 3, my 10, my -19, and 30. So that tells me nothing's missing doing that check real quick. So let's write out our numbers. 3, 10, -19, and 30. So I had to do this twice because it gave me 2 numbers to check. All right, there's my bar. And the first number I'm going to try is -5.
Oh wow, we're gonna have to do -5 and 2.
Yeah, this is like 2 problems in one.
Oh wow, I'm so ready for this. This is exciting.
Yeah, you think you only got one problem, but then they throw 2 numbers at you, right?
Right.
So y'all bring down my 3. All right, I need the next column.
-15.
Yep, 3 times -5 is -15. All right, add that up. So 10 and -15.
-5.
Oh, what'd y'all say?
-5.
Okay. All right, I need my next number.
25.
So -5 times -5 is 25. All right, so let's see. 25 and -19.
-6.
Oh, you're so close. But remember, when you're adding your larger numbers positive, so that's 6.
Oh, so it's 5. Okay.
All right, y'all, to my last row. So 6 times -5.
-30.
And I get a remainder of
0.
So my question is -5 a 0 of that polynomial?
Yes.
Yes. All because of that remainder. So now we're going to check 2. Now, y'all, I've seen these go yes, no, yes, yes, no, yes. I've always seen at least one of them be a zero. Sometimes they might both be zeros for y'all, okay? So write the same numbers, 3, 10, negative 19, and 30. All right, draw my bar. All right, so your first step,
Bring the 3 down.
gotta bring the 3 down. All right, next step.
2 times
2
10.
times 3 is 6.
So
Oh.
let's go in there.
16.
16. All right, next number.
32.
So 16 times 2 is 32. So basically, I want 32 minus 19 to be my next number.
Positive
13.
13.
There you go. All right, now get me my last number.
So 32
26.
times 2.
So guess what? I know I'm not getting a zero here. So let's see. What is our remainder?
4.
56.
Okay, 56. There you go. So it says you're adding them.
Oh, yeah. I thought it was the difference. Yeah.
That's the trick. You just got to keep remembering. We're not subtracting those. We're adding those every time.
I showed subtracted them when she said 56. I'm like, what happened? Okay.
Yeah, I was like, the difference is 4.
Well,
What do you mean?
the reason you're sort of subtracting over here is because you got unlike signs. And the rule for subtracting unlike signs is take the larger number, subtract the smaller number. So 15 minus 10 is 5, but we give the answer the sign of the larger number. So that's how y'all got that. So my question is 2 a zero of that polynomial?
No.
No.
There you go. All right. Woo, this one gave me 2 also. So this time I'm checking -1, +1. They're giving me h of x equals x to the 4th plus 2x to the 3rd plus 3x squared minus 5x minus 7. So 4 plus 1 is 5, so I need 5 numbers. I got a 1, 2, 3, -5, -7. So nothing's missing. So let's try -1 first. My coefficients are 1, 2, 3, -5, and -7. All right, who's leading me through this one?
Drop down
2
to
times 1 -2. Oh, my bad.
Drop the
Oh,
1.
yeah, bring down the 1. Yes.
-1 times
Uh-huh.
1.
-1.
And then 2 and -1.
So it'd be 1
2.
times -1. So -1.
Okay.
2
3 -1 is 2.
times -1 is -2. So it'd be -7
Oh, good job. -7.
times -1 would be 7. So that would be 0.
So that means -1 is a 0, true, right?
Yep.
Yes.
So let's check that +1. Now what's nice though is it's the same numbers. 1, 2, 3, -5, and -7. And y'all, I'll tell y'all, the problems for the college algebra 8.3 don't have any missing terms, but the one in the support did, say. Okay, so there's only one that you have to worry about really that has any missing terms.
So wouldn't these just be the complete opposite sign of what we just got?
Well, let's see. What are you going to do first?
Drop the 1.
Drop the 1. All right, so what's going next?
A 1.
There you go.
3.
The only difference is it's making my numbers different since I'm not adding, unlike signs, I'm adding
Oh, yeah.
positive signs. All right, what's next?
3.
Okay, what's next here?
6.
All right, next number on the column.
6. 1.
Uh-huh.
And then that'll be 1.
Uh-huh.
So that'll be a -7.
-6.
Because -7 plus 1.
Oh yeah, we add those. Okay,
So yeah, I think you tried to multiply that, and didn't you?
I did.
So
then that'll
yes
be
or no?
no.
Okay, there you go. That is definitely a no.
You know what? I'm so jealous of how fast this is going through Katie and the other person's head because it's there for me, but it's not going as fast as it is for the other. So good job, y'all. I'm getting y'all answers, but I'm taking a little longer, but that's okay.
Oh, that's all right. That's why God gave us technology, right? So this one wants to know is, so we all's favorite numbers is 1/2 a 0 of f of x equals x to the third plus 1/2 x squared plus 5/2 x minus 3/2.
No.
So guess what? Y'all start getting good with numbers. Guess what we throw at you?
Fractions.
We throw the fractions. So 3 plus 1 is 4. Guess what? I got a 1, 1/2. I got enough numbers here, so let's put our 1/2 over here for our C. Now let me tell y'all something. And guess what? These ain't bad since they got a common denominator. Now, if I'd had a 2 here and a 3 here and some other number here on the bottom, woo, that would have made these a little bit tedious, okay?
Does that
Are
happen?
gonna be ones like that?
Yeah, does that happen?
So here we go. We're going to bring down a 1 for my x to the third.
Wait, we just asked you a question.
Right.
Oh, what was the question?
Are they gonna have ones that have different numbers, denominators?
Oh, yeah, you can treat that like a 1/1.
No.
No, we asking when we run it. You just said that we lucky that the denominators are the same on those. We're asking, is there cases where they're not the same?
No,
They will always be the same. Every problem you give us, right?
they'll probably be halves just like mine. All they're going to
Okay, but
change
they're
is,
all gonna have the same denominator.
Yeah, they are gonna have the same denominator.
yeah.
Okay, that's what we're trying to
I
figure out.
even see Eugene because them tests you be throwing
Yeah.
little in there.
Yeah, that's why I was saying that. We're lucky they always have the same denominator on these, okay?
Okay.
Okay, so my next number is a 1/2 of 5/2 and then a -3/2. So leave me a little space because of fractions. But y'all watch, this ain't that bad. Even the ones y'all get will be really similar to this. So the first thing, you're still going to bring that 1 down, right?
Yep.
All right, so what is 1 times 1/2?
1/2.
So think about this. When you add fractions, you add the numbers on top and put them over that denominator. So this is 1 plus 1 gives me 2 on top. Well, 2 divided by 2 is
1.
1.
and that makes sense. 1/2 plus 1/2 is a 1. So now 1 times 1/2.
1/2.
Now add this and see what you get. Add the numbers on top and then divide by that denominator.
6/2.
Uh-huh.
3.
And 6/2 will give me a 3. Good job. So now 3 times 1/2. Remember, when you're multiplying a whole number times a fraction, this time you might treat it like a 1 on the bottom. Multiply straight across, what do you get?
3/2.
3/2.
All right, so 3 times 1/2 is 3 halves. Well, that makes
So,
sense.
Zero.
0.
And that is a
0.
0. So is 1/2 a 0 of that polynomial?
Yes.
Yes, it is.
Yes, it
But
is.
please do another one, Mr. Eugene.
Um,
Please,
well-
that was
hang on just a second. Let me see if MathLab will give me a different version of that. So y'all hang tight 1 second.
Please do another
you can
one.
make up the numbers. You can make up the numbers.
Oh, well, I don't know if I can make them up that work.
Oh, I see what you're saying. Okay.
That perfect. All right, so I'm zipping into Blackboard real quick. Let's see. There's just like 20 links to get to everything in Blackboard. You got to do the portal, then click Blackboard, then click MathLab.
Could you just do it with like I don't even know what I'm gonna try and say. Never mind. Like
Okay.
a 4 at the bottom, like a
Mm.
1/4 or something.
Oh, well, let's see if they give me one like that. So I'm pulling it up. What number was that? 5?
Yeah.
So I'm going to write the other number 5 in here.
All right.
So this, and it wants me to check 1/2 again. Now, this time they're giving me f of x equals x to the 3rd plus 5/2 x squared plus 9/2 x plus 9/2. So are y'all being able to see me writing that down?
Mm-hmm.
So apparently we're all going to get halves. The only numbers they're changing are the numbers on top of the fractions and some of the signs. See, up here I had a negative at the end where this is positive, but everything's still staying with halves. Okay, so our numbers will be a 1, 5/2, 9/2, and then a 9/2 at the end. So leave me a little space here and then my remainder. All right, y'all. So let's bring that 1 down. 1 times 1/2.
1/2.
All right, so y'all add this column and see what I get. I got 5/2 plus a 1/2.
6/2, which would be 3.
There you go. So it looks like they're always going to simplify down to a number. Now
I hope
remember,
so.
what is this? 3 times 1/2 give me?
3/2.
Okay. So add that 9/2 and that 3/2 and see what we get.
Be 12/2, which would be 6.
There you go. All right. 6 times 1/2.
Hold
Six
on.
over-
On that,
six
hold
over
on, Mr.
two.
Eugene. You just divided what by what to get the 6?
Oh,
I mean,
so
to get
9 plus 3 equals 12 on top,
And then
Okay.
divided by
2
that
into 12 is
denominator
6.
2. So remember, when you're adding fractions, you add the top and put that over the bottom,
Okay.
and then she just
Oh,
turn that into a 6.
right. Because when you divide that by that, it equals 6. Okay.
Right.
Okay. I got it.
All right. Let's see.
6/2.
6/2. Now, I probably won't reduce that one, but at that point, what's my answer going to be? Yes or no?
No.
No, because there's no way I can make that thing equal 0, right? But officially, if you wanted to, 9 and 6 give you what, a 15/2. But at that point, since them numbers didn't match up and be opposite in signs, that's a
Right.
big no when you move on. Okay.
Is it still going to ask for that number, though, for an answer?
No, no, that one just says yes or no.
Okay.
Okay. So y'all, that's the college algebra 8.3, just them 5 problems. Although some of them had 2 parts or even 3 parts, like them function values. it's all synthetic division, okay? So now to get us ready for Wednesday night, we're going to do support for 8.4. So let me get my camera back up. And this is just foiling practice, okay? Since y'all love to foil. So this is going to be support for 8.4. Because 8.4 is a little bit longer than we've been going through. So we'll probably need all the time for that one section. So support for 8.4. So the first 6 of them, they want us to multiply. So the first one, they want us to multiply W plus T times W squared minus WT plus T squared. Because we're going to foil stuff that looks like this. So y'all, the trick to foiling this is to take this W and multiply by all 3 of those. Then we'll come and get the T and multiply the T by all 3 of those. So let me see what you get when you do a W times a W squared.
W
W
cubed. No.
Mm-hmm.
W cubed. Okay.
Yeah, because you're just adding exponents, right? To W, 1 plus 2 gave me 3. Now, that W times that negative WT will be a negative what?
And you said the W times negative WT.
W squared T.
W squared T. Good job. Because the only thing that's happening is you're basically adding a W to everybody.
Yeah.
Now, how about this? W times T squared.
W.
Squared.
Ah.
WT squared.
There you go. So I just added one W. W squared turned to a W cubed. WT turned to a W squared T. And a T squared turned into a WT squared. Now let's distribute that T through here. So what is a T times a W squared?
TW squared.
Mm-hmm. So TW squared. All right. T times a negative WT.
Negative WT squared.
All right. And then the T times T squared.
T cubed.
Now, you see this negative W squared T? It's like terms with that TW squared because the W still is squared in the T. This one just ain't in alphabetical order here. But this would give me a negative TW squared, a positive TW squared. So what's happening with those two terms?
And cancel each other
cancel
out.
out.
They cancel out. Good job.
So I've never seen that before, Mr. Eugene. So
Yeah.
I see that the same. I'm saying I never seen that before. But I see they're the same thing. They're just reversed, but they're
They're
still
just out of order. So
and
if
it
you want
still
to,
is okay.
So if
Okay.
you wanted them in alphabetical order, you could just make this a negative TW squared, a T squared W here. If you wanted them in alphabetical order, but all I'm looking at is the variables have to match up with the same exponents. So this WT squared here is like terms with this negative WT squared. So y'all, what happens to those?
Cancel out.
They cancel also. So 1 and negative 1 canceled here, negative 1 and 1 canceled on that one. So all that's left is what? A W to the third
In a T cube.
and a T cube. There you go. All righty, watch this one. R minus G times R plus G times r squared minus g squared. So y'all, tell you a trick on this one. I would FOIL these two first. Once we FOIL this, we'll take that answer times this one. So I'm just going to do that part on the side. The r minus g times the r plus g. Now, y'all, here's the thing. The reason I picked these two first, these are what we call conjugate pairs. One's being subtracted, one's being added. Other than that, everything's the same. So when you multiply conjugate pairs like this, you'll notice the inner stuff is going to cancel every time. So y'all watch this. R times R.
Yeah.
R
R squared.
Uh-huh. Now, I'll keep these ones in alphabetical order for you. R times G.
RG.
All right. Negative G times R.
Negative GR.
And then that negative G times that G is a negative
G squared.
G squared. Now, that's a RG and a negative GR, but ain't they like terms?
Yes, because they just backwards.
I could have wrote this one as a GR and a negative GR. But y'all, that's the property of these conjugate pairs, is that the middle terms always cancel. And I end up with a R squared minus a G squared. So the first two terms turn into a R squared minus G squared. And what's left up here was a R squared minus G squared. Now, y'all, guess what? These are not conjugate pairs because these are both negative. So these ones won't cancel out like the ones that are opposite in sign did, okay? So y'all, let's see what y'all do here. You got an R squared times an R squared.
R4.
All right. Now, I got an R squared times a negative G squared. So I know that'll be a negative what?
R squared, G squared.
Okay. Right here, you got a negative G squared times R squared.
And it's a negative G squared, R squared.
And then how about that negative G squared times that negative G squared?
Negative.
To the fourth.
Now,
Oh, you made it positive? Okay.
Because remember, negative times
Oh,
negative.
yeah. Sorry.
Now, these are like terms. They don't cancel because they're both negative. So bring down that R4. A negative 1 R squared G squared and a negative 1 G squared R squared are like terms. So that's going to give me a negative 2 R squared G squared. And then at the very end, I got a positive
G to the fourth.
G to the fourth. Now, MathLab will take it in any order right here. You can do G squared R squared or R squared G squared. It'll take it either way. So y'all, guess what? That was multiplying real numbers. What about this? A negative 4i times negative 4 plus 3i. Now, y'all, let me show you something. We're going to be multiplying I times i's. So I times I will give me an I squared. And y'all, I squared equals negative 1. Anytime I get an I squared, I'm going to replace it with a negative 1, okay? Now, these can be done on the calculator, but I'm going to do it by hand first, okay? Now, when you write these answers in MathLab, they always want it in this form, A plus BI. So we got to put the real number first and then the imaginary number if we got it. So y'all, we're going to distribute that negative 4i times that negative 4. So what's a negative 4i times a negative 4 give me? Well, that's going to give me a
16i.
16i. There you go. Now, what's this negative 4i times 3i going to give us?
Minus 12i squared.
So negative 12i squared. But what did we say I squared equaled?
Mm.
Oh, I was
Oh, no.
hearing it. So remember, I squared equals negative 1. So since I got an I squared here, I'm going to replace it with a negative 1. So bring down to 16i. And what's a negative 12 times negative 1 doing?
Multiplying?
Uh-huh.
It's gonna be a positive 12.
Positive 12. So check this out. All that I squared did in the long run was turn that 12 from negative into a positive, okay? Now remember, the answer has to be in this form, a plus bi. So we're sort of backwards. So my final answer would be 12 plus 16i. But y'all, what's nice? Any of these with these imaginary numbers, let's go to the calculator. We can do those on the calculator. So you're going to do negative 4. The I, you see the I is right above the decimal? And the I is blue. So you would hit the second decimal, and there's your I. Then I got my parentheses, and I had a negative 4 plus 3i, so that'll be 3, and then second decimal, and then I'm going to close the in parentheses. And y'all watch this. What do we get? 12 plus 16i? Watch this. 12 plus 16i. So just remember, the I is the second decimal, and that calculator will do all of these with the I's in them, okay?
This was the best invention ever.
I know that's right. All right, let's see. My page went down a little bit. All right, so number 4, 8 plus 2i times 3 minus 6i. Now I'm going to do these by hand, but you can do this on the calculator also, okay? Just put them in their parentheses. All right, y'all, so let's FOIL. 8 times 3 is 24. 8 times negative 6i is a negative 48i. Now I'm going to do the 2i times 3 is a positive 6i. And then at the end, 2i times negative 6i is a negative 12i squared. So there's 2 things I'm going to do. I'm going to add like terms in the middle. And we're going to turn that I squared into what?
A negative 1.
A negative 1. All right, so bring down your 24. So y'all, a negative 48 plus 6 gives me a negative 42i. And if we turn the I squared into a negative 1, I got negative 12 times negative 1, which will make that a positive 12. So that is I squared's only purpose in life. Change the sign of that number in front of it. Okay? So can you do anything with this?
Yes.
All right, what are you doing?
Putting the numbers first,
So you
then
got so the numbers now become my like terms. All right, so 24 plus 12,
36.
and then bring down your minus 42i. So y'all, if you punch this right here on the calculator, it's going to give you 36 minus 42i.
Because that's exactly what I got.
There you go. Now watch this one. 2 plus 6i times 2 minus 6i. These are conjugate pairs. You got a plus 6i, minus 6i. Everything else is the same on these. Check this out. When you FOIL conjugate pairs, you end up with a single real number. So y'all, let me show you how that happens. 2 times 2 gives us a 4. 2 times negative 6i gives me a negative 12i. But watch this. You got a positive 6i times 2, which gives you a positive 12i. So those are canceling smooth out. Now, 6i times negative 6i is a negative 36i squared. So y'all, those two in the middle are going to cancel. And once again, what's happening to that negative 36i squared?
times it by -1.
So I bring down my 4. That stuff canceled. So what happened at that negative 36i squared? You turn that into a -1, and that become a positive 36. Okay, so y'all, that's all that I squared does, is it changes the sign of the number in front of it. Oh, and y'all, can you do anything with that? Well, those are like terms.
Add them.
So 4 plus
40.
gives me a 40. So conjugate pairs will end up with a single number. No i's will be left. The i's cancel out every time. So y'all, 9 plus 7i times 9 minus 7i. Conjugate pairs again. So watch this. We'll end up with a single number like we did on that one. All right, y'all. 9 times 9, 81. 9 times negative 7i, negative 63i. 7i times 9 is a positive 63i. And then the 7i times negative 7i is a negative 49i squared. So look, the conjugate pairs did that again, didn't they? Negative 63, positive 63i. Those cancel. So what are you doing to negative 49i squared? Well, you're going to change the I squared to a -1. And that -1 times that negative 49 made that a positive 49. Now, check this out. Are y'all noticing that on the ones that are conjugate pairs, the last number always ends up a negative something I squared, and it always turns positive. Ended up with a negative I squared, but that turned it positive. Okay? All right, y'all. So, what's that? 81 plus 49? What are we getting? Like a 130?
130.
There you go. All right, y'all. So this last one is not a FOIL or nothing. The last one, they just want us to solve x squared minus x plus 2 equals 0. So I would try to factor that first, but I got a 2 sitting here. And since that's plus, I need factors of 2 that would add to get a 1. Well, y'all, 2's prime, and the only factors are 1 and 2. And 1 plus 2 does not equal a 1 in the middle. So I cannot factor that to get that middle. So this does not factor. So y'all guess what? Since that does not factor, we get to use our friend to solve this one. And the way we're going to solve it is our friend, the quadratic formula. Negative b plus or minus square root b squared minus 4ac all over 2 times a. So we just had to give you a little bit of quadratic formula help, because guess what? In 8.4, we're going to use the quadratic formula again. So y'all, a is 1, b is negative 1, c is going to be 2. So a is 1, b is negative 1, c is 2. So y'all, I'm just going to start plugging in. So bring down your negative. Put in b, which is negative 1, plus or minus. B squared is negative 1 squared, minus 4 times a, which is 1, c, which is 2. All of that over 2 times a, which is 1. All right, now we're just playing simplify this thing. 2 negatives make that a positive 1, plus or minus. So most of our work is under the radical. A negative 1 squared, negative 1 times negative 1 is a positive 1. And y'all look at this. All this stuff being multiplied only has 1 negative, so it's going to stay negative. So negative 4 times 1 is negative 4. Negative 4 times 2 makes that a minus 8. All of that over 2. All right, y'all. So we're still playing with the radical. So I got 1 plus or minus square root. 1 minus 8 makes that a negative 7. All over 2. So y'all check this out. Can I do anything to simplify this radical? So on the side, I'm saying, can I do anything to that radical to simplify it? And y'all remember, there's at least one thing I got to do to that. What did we do if it was negative under those radicals?
Put the I.
Yeah, because I'll make that a negative 1 and a 7. But then the square root of negative 1 gave me I, so that's going to equal to I square root of 7. So if you can't take the square root, you at least got to bring that negative out from under that radical and put an I there, because that now means this is an imaginary answer. So let's put that over here. 1 plus or minus I square root of 7 all over 2. But y'all remember, I got to write my answers into a plus bi form. So we got to turn this into 2 fractions. So remember, this denominator affects both sides. So this side will be 1 divided by 2. Plus or minus. And then we put the I square root of 7 over 2. So when you got a single fraction like this with an imaginary, they want them broke apart so that we have our real part first and then our imaginary. Now you could also write that as a 1/2 plus or minus square root of 7 over 2i. So it'll take it either way, okay? I usually just do this one because it's easier. But it will take it if you put the I behind that second fraction. So y'all, this was just to give you more practice from that quadratic formula we did back in what was it, 4.8 and 7.4. All right, so that's our support for 8.4. So it's mainly getting you used to doing this foiling stuff because y'all, when we start in Monday, we're going to start right out. I mean, Wednesday, we're going to start right out foiling stuff, okay? All right, y'all. So I'm going to quit my share. So you got 8.3 support, 8.3 college algebra, both doing synthetic division. And then you got 8.4 support, doing a little bit of multiplying, okay?
Mm-hmm. Okay.
And y'all, that is all I got for tonight. So I'm gonna quit my recording real quick so that we can get them sent out later.